4.1, exploring the primary trigonometric ratios of all obtuse angles. So we've gone from acute angles, which is less than 90, to obtuse, which is greater than 90. Okay, just a little bit of a review here. If we're given a 90-degree triangle and we're looking at theta, this angle is our reference angle. In reference to this, this side is called the hypotenuse. This side is directly opposite. Oops. See if I can make that move where I want it to move, is opposite. And this side is adjacent. So now when we're using trig ratios, we have sine, which is so katoa. So sine is opposite over hypotenuse. Cos is adjacent, the ratio of the adjacent side to the hypotenuse. And finally, tan is opposite over adjacent. So all these trig ratios are just that. They're ratios. No matter how big your triangle you have, the tangent of an angle, even if it's a small triangle, big triangle, the tangent of 30 degrees is the same ratio, even though your side lengths may change. So these ratios are going to help us to solve triangles. Okay. What I want you to do before we go any further, before we go on, is I want you to go to the course, and there's something that's called 4.1 Print Me First, right here. And I really want you to have that, and I want you to have it printed. And what it looks like when you print it out is something like this. And I'm going to fill this in, and I'm going to press pause at some point, and you're going to continue filling in this table, and you're going to notice a pattern when you fill in this table. You'll also need a calculator. It needs to be in degrees rather than radian. It has to be a scientific calculator as well. Okay, so we're going back to here. Until now, we've used the primary trig ratios with acute angles, so angles that are less than 90 degrees. For example, you use these ratios to determine side lengths and angle measures in right triangles. And you've used the sine and cosine laws to determine the side lengths and angles in these acute oblique triangles. And oblique means that there's no 90 degrees. It's any triangle that isn't a 90 degree. So that's what we did in chapter 3, use the sine and cosine law. Okay, now we have Joe here. He investigated the values of the primary trig ratios for obtuse angles. Using a calculator, he determined that the value of the sine of 100 is 0.9848. So he took his calculator. Come on, calculator, where are you? There you are. He took his calculator and he went 100 sine. And some people have to do sine 100, it just depends. And you could see that he got 0.984, repeating. He knew that he could not create a right triangle with a 100-degree angle. However, he knew that he could create a triangle using the supplement of 100, which is 80. Out of curiosity, he evaluated the sine of 80 and determined that it has the same value. He decided to broaden his investigation and created a table like the one below. So that was really interesting. In his calculator, he found that the sine of 100, which I did right here, was 0.984. And also, if we did 80 sine, we got the exact same number. He said, wait a second, I'm going to see what's going on here. I'm going to see the relationship between angles that add up to 180. I'm going to see if there is some sort of relationship between the sine, cos, and tan. And that's what we're going to do together right now, and then I'm going to press pause and you're going to finish this. Okay, so he saw that the sine of 100 was 0.98. 180 minus 100 was 80, and the sine of that was 0.98. Okay, we're going to do the same thing for cos, tan, and see what we get. So I need my calculator. I'm going to go the cos of 100. So 100 cos, and some people do cos 100 depending on your calculator. And we get a negative. We get negative 0.173. Negative, oops. Negative 0.173. Okay, and now let's try the cos of 80. So we're going to do 80, and we're going to get cos. And we get the same decimal, but it's no longer negative. We get 0.173. Sorry, my pen's not working all the time. 0.173. Okay, and finally, let's do it for tan. So the tangent of 100, first of all, so 100 tan, and we get negative 5.67, negative 5.67. And now let's try the tangent of 180 minus 100, or the tangent of 80. Oh, I lost my calculator. Okay, so we're going to go 80 tan. And look, we get 5.67. So the same decimal, just not negative. 5.67. Okay, so what I'm going to do now is I'm going to get you to try all of these angles. You're going to have to press pause, get out your calculator, fill in your table that looks like this, and we're going to see what relationship exists. So press pause. When you start pressing play again, all the answers will be here, but it is a good exercise to go through and do this work. Okay, so you've completed the table and you should notice a couple of patterns. The first pattern, the main pattern that I want you to notice, is that the cos of any angle is equal to, is the negative of the cos of 180 minus that angle. So the cos of 100 gives you a negative number. The cos of 80 gives you that same number, only positive. Okay, sine ratios are the same. The sine of an angle and the sine of its complement, his supplement is always the same. Tangent, the tan of 130 is equal to negative the tan of 50. So these are the same number, just a negative sign difference. Some of you might also notice there was a relationship between sine and cos. You can see that 0.173 was also found here. Okay, some things that I didn't do very well in this table is I didn't do it to always the same number of decimals. I was looking more at patterns. Sometimes my rounding might not have been the same as yours. I was more looking for relationships as opposed to that accuracy. So just a little disclaimer there. Okay, so the relationship we observed when comparing the ratios for obtuse with the related supplementary acute. So you'll notice that these are all acute and these are all obtuse. We notice that they're the same ratios when they're sine, and cos and tan are just that difference of that negative. So here they summarize it in a beautiful way, and this is in your textbook as well. There are relationships between the values of the primary trigonometric ratio for an acute angle and the value of the same primary trigonometric ratio for the supplement of the acute angle. For any angle, the sine ratio of an angle is equal to the sine of 180 minus theta. Cos of an angle is equal to negative cos of 180 minus theta. Some of you might say, well, I wish they would have put the negative here. They would have said negative cos is equal to cos of 180 minus theta. And it's the same thing, exact same thing. Times both sides by -1, and you get the same thing they wrote. So don't worry about that. The tangent of any angle is equal to negative the tangent of 180 minus theta. So there's a couple questions that you guys need to try, and this is a pretty simple section.